right, so yesterday you learned how to name common polyatomic ions, okay? Now, just to give you a little bit of information on the importance of some polyatomic ions, so we're going to get into writing formulas here in a minute, but I wanted to kind of tell you guys a little bit about when you ask, well, why do I have to know this and things like that? Well, because the reason you have to know this is because, for example, hydrogen carbonate, hydrogen phosphate, and dihydrogen phosphate are actually very important ions that are used in our blood to transport nutrients all over our body. So as you can see, that's a very important factor that we need in order to survive. Okay, what's also interesting is 2 of those polyatomics are also used in fertilizers to help transport nutrients to the different forms of vegetation that farmers use to grow plants and vegetables that we eat every day. So I find that very interesting that it's also used in fertilizers to help give food and nutrients to the plants, and it's also used in our blood to transport these nutrients to different parts of our organs and body parts so that we can actually survive, like our heart, liver, kidneys, and so on. Okay? Now, let's get to how, this is going to be a little more complicated than what we did yesterday, okay? Because writing the formulas, there's just one more added thing that we don't do when we write binary ionic compounds, okay? So when you're doing this, you're going to start off the same way as we did with binary ionic. You're going to write the symbol for the cation, the positive ion, and then you're going to follow it by the formula for the polyatomic ion. So in that case, that part's going to be exactly the same. So for example, if we have something, if they say, okay, I want you to write the formula for calcium nitrate, okay? Very first thing you're going to do is go to your periodic table and find calcium. We know that calcium is Ca. Then you're going to go to that box on that periodic table of ions and you're going to find nitrate. Remember, they're alphabetical order. So go and look for nitrate and you would see that it's NO3. Then you're going to write your charges, okay? Calcium is a +2, nitrate is a -1. Notice what I did here. I didn't just put the charge on here. I put the whole ion in parentheses and then wrote the charge on the outside of the parentheses. The reason is I don't want you guys to get used to thinking if I write a -1 charge that -1 is on the oxygen and not on the whole ion, okay? So it's very important that you look at it this way. So the whole nitrate ion has a -1 charge. Now remember, back to what we did with binary ionic. If the charges do not cancel, so a +2 and a -1 do not cancel. If that's the case, we use our crisscross method, right? Where we crisscross them. So the 2 goes here and the 1 goes here, right? That's one way to do it. Okay, so what we're saying is it's going to take 2 nitrates to cancel out 1 calcium. Because you remember, you want the charges to equal 0. So if this is a +2 and that's a -1, I need a -2 in order to cancel out so that my charges are equivalent to 0. The only way I can do that is by having 2 nitrates for every 1 calcium. Now, once you do this, a common mistake people make is they don't put the NO3 in parentheses. If you are writing a subscript outside, or you're writing a subscript on the polyatomic ion, you have to put the polyatomic ion in parentheses. Otherwise, you're actually changing what this is. If you don't put parentheses here and then you go ahead and put a 2 there, that's going to be NO32, and that doesn't even exist. It's not even possible, okay? So it's very important that when you are doing polyatomic ions and you're writing a subscript at the bottom, meaning you're writing how many you have of that particular element, you must put it in parentheses so that you're showing that you have 2 nitrates, not NO32, okay? All right, now here's another one. What if I had sodium nitrate as one of mine? Well, sodium has a +1 charge, nitrate has a -1 charge. If the charges cancel out, you write them as is. So you can write it as NaNO3. Now, some people like to keep the NO3 still in parentheses. I will not take off if you still put parentheses around the NO3, okay? I will take off if you don't put parentheses around it and then you try to write a number outside. That's wrong, okay? All right, so let's do some more practice. What are the formulas for these ionic compounds? If I have magnesium hydroxide, shown in the photo as milk of magnesia, and I have potassium sulfate, how would I write these formulas? Well, first of all, you would go and you would write what these are. So I'd go and I'd find magnesium, and it's a +2 charge, so Mg has a +2. I would go and find hydroxide. Hydroxide has a -1. Remember, watch what I do. I put OH in parentheses, and I put a -1 outside the parentheses. A +2 and a -1 do not cancel. So remember, you're crisscrossing. You drop your charges. You never write charges at the bottom. Drop your charges and crisscross the numbers. So now when I have it, I've got Mg parentheses OH in the parenthesis and put a 2 on the outside of the parentheses. Okay, because I need 2 hydroxides to cancel 1 magnesium. Then I go and look for potassium sulfate. I go and I find potassium, so it's K with a +1 charge. And then I go and I find sulfate, which is SO4. Remember, putting the whole SO4 in parentheses and putting the -2 on the outside of the parentheses. Once again, a +1 and a -2 do not cancel. So if they do not cancel, you crisscross the numbers, dropping your charge, and you're going to end up with K2SO4. Once again, some people like to leave the SO4 in parentheses. That is okay if you want to do that, okay? It's not wrong if you want to go ahead and leave it in parentheses, all right? All right, the next one, write the formulas for the compounds formed from these pairs of ions. So I wanted to throw this in here because this is your only positive polyatomic ion, which is ammonium, okay? And it has a +1 charge. And then you have sulfite, which is a -2, okay? And then you have a calcium ion and a phosphate ion. So we're going to go ahead and show you what these would look like in their formulas. Okay, so NH4 was a +1 and SO3 was a -2. +1, -2 do not cancel. You drop your charge, crisscross the numbers, so the NH4 gets a 2. Now notice, I put the NH4 in parentheses because it's still a polyatomic ion. Remember, when you have a polyatomic ion, you have to put it in parentheses before putting the subscript. And then you write the SO3. If you wanted to leave the SO3 in parentheses, completely okay. And then the last one, we have the calcium ion and the phosphate ion. So calcium is a +2, phosphate is a PO4 with a -3. They don't cancel, so you crisscross the 2 and the 3. The 3 goes to the calcium and the 2 goes to the phosphate. Crisscrossing the numbers, dropping your charges. Okay? So, I hope you enjoyed today's lesson. Remember, you're going to get a worksheet followed by this today, and you're going to be working some of those out. Please, please, if you have questions or you need help, just email me, and I'll get back to you as soon as possible and try to help you with those worksheets, okay? You are going to have a quiz this week over ionic compounds, okay? So be sure and look over your material. I think that's on Wednesday or Thursday, not real sure, but look over your material and do that. I actually think it's on Thursday. You're going to have a lab tomorrow, so we'll go ahead and get started on the lab, okay? All right, see you guys then.